Bismillahirrahmanirrahim. My name is Tawfiq Mahmood. This is an article-based presentation, and the is about a research paper. The name of the research is the edge detection with LSB and AES encryption-based image steganography. And as you can see, I've also attached the front page of the research paper, where you can see there are 4 authors of this research paper. And we uh, if we introduce our authors, then in the first there is Sheikh Tanbir Alum, who is a faculty of electronic engineering and technology in University Malaysia. And the second author is Munira Tabassum Mou, Department of Software Engineering in Deafar International University in Dhaka. Third author is our beloved Professor Muhammad Maruf Hassan, who is in Department of Computer Science and Engineering in Southeast University, Bangladesh. And the fourth author is Tawhid Bhuiya. He is in School of IT, Washington University of Science and Technology. So let's dive in what this research paper has actually been said is talking about. So as we are diving in, here is the roadmap that this presentation is gonna is gonna. This is the roadmap of the presentation. First, we are going to talk about the background, then research gap, problem and scope, literature and review, methodology, results, and future work. So let's dive in more. The background of the study. Before knowing the background of the study, the research paper actually based on a very simple question, yet a powerful thinking process. The simple question is, how can we send a text that is embedded into an image or in a file? Here in this research paper is about image, so let's stick to the image. The question is how any message we can hide into an image. This is the question. So the answer of this question is the whole research paper. So let's study the background of this research paper, and that is internet communication is easy to intercept, copy, and analyze. So how can we send a message which we first encrypt and then put it into a normal image so that no one understands what is this image is about, and is this image is about hiding any important message or not? This is the background study. Cryptography makes data unreadable. Stenography hides data inside ordinary media. Combining both gives stronger protection. Images are useful because tiny pixel changes can be hard to notice. So what are the tiny pixel changes? We are going to talk in later slides. Let's learn about the basic terms, because as we are going to dive in, there are lots of important methodology and also words that we have to introduce in the first hand. The basic term is the normal picture plus the secret message that we are going to hide is equal to Stego image. This is the meaning of Stego image, is that a normal image and the secret message. This is the formula. Then we need to learn about the cryptography and stenography. The cryptography is about to convert a readable message, here hello, to an unreadable message, as you can see in the example. Cryptography protects message content, looks suspicious if intercepted, needs a key to read. In the steganography, it's about normal looking image, which image secretly contains data. Conceals communication itself, here looks like an ordinary file, needs a known extraction method to extract the data here. Then there is about AES encryption, which is advanced encryption standard. It's about, in this message, AES has 128-bit key. So the plain text become a cipher text based on the key 128-bit key. The receiver needs the AES key to decipher the extracted data. This adds a second security layer if the hidden data is discovered. So here we are talking about hiding a data inside an image so that no one understands that we are sending actually a data or a message, encrypted message to the receiver. So even if somehow that data, someone understand that this message actually contains a secret data, even if he extract the data, he will find it in an encryption method, an encryption form in ciphertext. So then again, he will face problem to decipher the text. This is the key idea here. Then there is pixels, binary, and LSB. And in short way, we can say that if we are taking 150 as a value, which we convert into the binary form, as you have seen in the screen. So later, if we change it to 151, only one bit has been changed. As you can see in the last, in 150, the last bit was 0 in the binary form, and in 151, the last bit is 1 in the binary form. So this is the very slight change, and if this small change will have pixelated issue, but this issue will be very small for human eyes even to detect or notice. So this is the concept here. So let's talk about the problem statement. What problem is the research trying to solve here? Traditional image steganography can hide data but may create visible distortion. Use predictable embedding location to become locations or become weak if attackers detect the hidden message. So here, therefore, the study process a method that encrypts the secret message into a AES, Advanced Encryption System, 128-bit. Select edge pixel using Sobel detection, embeds data with a 1-bit LSB and XOR method, and keeps the Stego image visually close to the cover image. So if we are going to say it in one simple sentence, that is, hide a secret message inside the picture without making the picture look changed and without exposing the readable message. So what are the scope of this research? The scope are, the first, we are going to have a cover image which can be in PNG image. In this research paper, there was PNG image, so let's talk about the PNG image. The main image that we are going to convert or use to hide the data, we are we are identifying it as cover image, cover media, which is a PNG image. Then pixel selection, we will select the pixel with the Sobel edge detection, and then implementation, which will be in C# and .NET framework. Encryption, which is based on AES 128-bit key. Embedding, which will be 1-bit LSB or plus XOR method. Evaluation will be PSNR, MSC, and RMSE. So not the full universe of steganography. This paper tests one clear method on a standard image. So if we summarize the literature review here, in 2019, the edge was fuzzy and Krish edge detection. In 2019, OAP plus edge detection. 2020, it's become LSB plus Hamming Canny DCT. 2013 to 2020, it's RSA DES hash LSB and hybrid method. And prior works are static or predictable pixel section, which is weaker against the attacker. So the pattern in literature is edge regions are commonly preferred because they tolerate small changes better than smooth regions. So here we are talking about how we are, as we have seen that in the LSB method, we have taken 150 as message, and we have changed the last bit of the binary conversion of the 151, which in the binary form the last bit become 1. So we are actually targeting the edge here, not the other part. The edge we are trying to change very slightly which is so that the smoothness can still be there. What are the research gap? In the research gap, we can find that predictable LSB pattern here, distortion in smooth regions, limited protection if data is found, and need balance, which is security plus quality. The proposed response are encrypt before hiding, so discovered data is still unreachable. Use Sobel edge, so embedding happens where changes are less visible. Use 1-bit LSB to keep pixel modification very small. Use XOR logic for embedding and retrieval. Proposed method overview. So what are the proposed method overview that has been discussed in this research paper? And that is the secret message. You're taking the secret message, you have put it in the AES encryption, which then binary conversion, then we have applied the Sobel edge detection, and then we have applied the LSB XOR embedding method, which finally turned into Stego image. So important idea here is that the media does not hide readable plain text, it hides the encrypted ciphertext. The security layer 1 is AES encryption here, and the second layer of the security is hidden image embedding. So what is the methodology? If the methodology is about input secret message and cover image, encrypt the secret message using AES encryption encryption system 128, convert encrypted data into a binary bits, use Sobel to filter suitable edge pixel, and embed secret bits and metadata into selected RGB pixels using LSB and XOR. So this is the methodology of embedding process. So what is the methodology of retrieval process? Because we are not gonna send data to the receiver. The receiver has to retrieve this data. So what is the process of retrieval? The retrieval process is input the Stego image, detect the same filtered pixel, extract hidden bits using XOR and LSB logic, rebuild the ciphertext, use the AES key to decrypt and recover plain text. So that is to get a Stego image, then turn it to the ciphertext, and turn it to the plain text. So let's talk about the Sobel edge-based pixel detection. The intention is smooth area reveals changes more easily, edges and texture naturally changes quickly. Sobel detection is stronger brightness changes. The article reports edge pixel ratios, which is Lena 27, as you can see in Lena 27%, in Baboon it's 58%, in Parrot it's 33%. So more textured image is equal to more possible hiding location. The more texture the image has, the more hiding locations you will get here. That is the intention here, based on the Sobel edge-based pixel selection. So the experimentals, let's talk about this experimental setup. So three standard images that we have seen in the previous slide, which you can also see in the research paper. And those images about Lena, Baboon, Parrot, we take 512 into 512 image dimension. We will take a PNG file, and the implementation platform will be C#. So payload size tested 512 bytes, 256 bytes, and 128 bytes. Quality was measured using PSNR, MSC, and RMSE. So result metrics based on PSNR, MSC, and RMSE. So PSNR higher is better, MSC lower is better, and RMSE lower is better. Let's memorize this so that when we are gonna see the next slides, you will understand which is better based on these parameters. So if we describe it more, we can say that PSNR means peak signal to noise ratio. It compares image quality before and after embedding. And MSC measures average error between cover image and Stego image. And RMSE is the square root of MSC and represents distortion in more direct scale. So that means good steganography is equal to high PSNR plus low MSC, RMSE plus visually low normally image. So here let's compare the result. 512 byte payload in the proposed model was Lena, PSNR is 68.3211, MSE was 0.027. For the baboon, you see there, this is the PSNR of 68, almost 69, MSE is 0.0026. Parrot PSNR has almost 70, and MSE is 0.0026. So no, very slightly change in MSE in 3 images, but there is also a slightly change in PSNR. So conclusion from the result, we can find that the proposed method maintains high image quality while hiding encrypted data. So conclusion, the main conclusion here, AES protects the meaning of the message. AES, which is the encryption method, Steganography hides the existence of the message into the image. Sobel detection improves where the data is hidden. 1-bit LSB keeps distortion small, and results show high PSNR and low MSE RMSE. So in the diagram, as you can see, secure message hidden inside the image. The message is secured by the AES method, and it is hidden inside the image, and very low visible distortion. The distortion happen because we are going to change the image pixel while we are hiding with the Sobel edge detection pixel method. So here the key contribution is the combination of AES plus Sobel plus LSB and XOR method. Now let's talk about the future work. This research paper has a scope of future work, as you can see, and those are, if we apply machine learning, we can find out more, we can do more, we can select pixel in more smarter way. And as we have discussed before, the more we can find out, the more we can find out the scope inside the pixels of hiding data, the more this will work. So we can apply machine learning in the overall process for smarter pixel selection. And then stronger resistance against steganolysis and attacks. Then dynamic key generation for improved security. As you can see, this research paper is using AES encryption method of 128-bit. We can use more dynamic key generation method for improved security. And then testing with more image formats. As you can see, in this research paper, we have used the PNG format, which is only one format of all the image formats. We can use more formats like JPG, AVIF, and other image format, and we can use large data set. We have in this research paper and in this presentation we have shown 3 image. So here we can have scope of applying the test with more image formats and with larger data sets. So this is the future work. And if we are going to talk about the references, this research paper has 22 references. So we have attached the references here. As you can see, there are 22 references in the research paper. So as we have came out in the conclusion of this presentation, and you have bared with me this long, if we summarize the whole research paper, we can find this research paper is about mainly having a data and turning it to the cipher data with the AES encryption method into the binary, and using the LSB and XOR embedding method to turn it to the image by selecting the pixel of the image. As we have come to the final section in the ending of this presentation, and you have bared me for this long, so let's summarize what we have seen in this overall presentation. This presentation is mainly answer a simple question. This question may be simple, but the finding and the research is profound here. The question is how we can send a data. First we will encrypt, and then how we will send a data in a way so that no one understands that this file or this sending method has actually a data embedded into it. This is the main question, and in return the answer is the whole research paper, which explains how we can actually achieve that. We have used PNG image, And what we have done is that we have taken a message like hello or 150, and we have turned it into the ciphertext based on the AES 128 encryption method, and we have turned that into the binary method using the LSB and XOR embedding. And based on the LSB and XOR embedding, we have turned it into the we have taken the cover image, the PNG, the original image. We have combined them and turned it to the steganography image. So this is the whole idea of the research paper. And inshallah, if we work on the research paper in the methodology of the research paper more, we can achieve more success on testing on the more image formats and with more larger data set. And if we apply machine learning into it, we can find more smarter way to find the pixel selection. And the more we can have scope of the pixel selection, the more scope that we have selecting the pixel, the more scope we can find to embed our message, that ciphertext, so that no one can understand. So basically, we will send a data through an image so that no one understand that this image actually contains a message. And even if someone understand or find out the message, it will be in the ciphertext, which will be in the AES, which will be ciphered by AES 128-bit method, so that he cannot decipher and find the normal or the plain text or the original message. So by summarizing all about the research paper in a very short time, I'm here concluding this presentation. Please feel free to ask any question that you can have. Assalamu alaikum.